Okay, this is lab number 11, tank blowdown. We're going to be using the same compressed air tank that we've used in a previous lab. You should have read through the lab report, and I want you to take a few minutes to go through that with your group. Make sure that you understand all the parts and the things that you're going to be looking at before we take the data. So go ahead and pause the video now and talk with your group about the sections in the lab. Okay, make sure you pay close attention to the safety section and what's needed there. The tank compressed air is around 75 psig, and we're going to make sure we're careful to wear eyeglasses for this experiment. In terms of the background, we want to be able to estimate how long it takes to empty a filled tank with gas through an orifice or valve when we know the discharge coefficient. You will have computed that discharge coefficient and geometry in your previous lab, and you can use that data again here. So the actual experiment is problem number 2. We're going to fill the tank to its max pressure, then close the filling valve, and then allow the pressure to equilibrate. And then you should talk with your group to see, okay, how long is it going to take to discharge, and you can get a sense for that from your previous lab and take the data down, and you'll be able to do that from the data directly off of the video. And then you'll record the time and the tank pressure while emptying through the orifice, and then we're going to produce a plot of the data, which is shown here, an example. So you'll plot your data versus the experimental data, and then you'll compare the expected value from theory based on adiabatic assumption and based on an isothermal assumption. Okay, so let's go ahead and have you pause the video and talk with your group about what kind of time series you would do when recording this data. Okay, we'll go over here to the tank apparatus and turn on the flow valve, turn on the main valve, and that will start filling the tank with gas. You can see the pressure rise, 25, that'll get up to about 75 psi. Notice that I have this pressure relief valve turned off. It has a lower setting than on the far side, allowing the pressure to get all the way up to 75 psi. It's about 80, and we'll turn it off. Okay, so just for fun, we'll start it at about a little bit higher than that. Fill the tank up to about 80 as our starting point. Okay, and then we'll just let that equilibrate for a moment. And then we're going to let the flow discharge through one of these flow valves. And I'll use the valve here in the back. This is going to be H35BR is the valve that we'll use. That's this one here in the back, H35BR. And just waiting here, watching the pressure, 79.1, 2, 3. Okay, that seems relatively stable. So let's go ahead and open that valve now, and you can watch the timer along with the corresponding pressure. And there's still a little bit of flow, but it looks like it's done. Okay, let's go ahead and do this experiment again on one of the other orifices. So we'll open the valve to fill the tank up again. Maybe. Okay. Okay, turn the valve off. Now we can see the pressure, 81 point, and the pressure's dropping. We'll just kind of let that equilibrate. 5, 1, 5, 1. Okay, that looks relatively stable. Let's go ahead and open. This will be, let's do this valve H40BR. And this is the biggest one. And then you can watch the pressure change as a function of time in this unit. Okay, and that's about finished there.